даже
in Russia, and then when it came to giving a talk, it made me think about some things that transpired between both of our societies some decades ago. For example, in 1957, when the Soviet Union launched Sputnik, the world's first man-made satellite that orbited the Earth successfully. Back in the USA, everybody freaked out about this. They didn't like being behind in space and said, oh my God, we got to catch up. We have to get a satellite into orbit in 90 days, which seems crazy. And it was. Our first attempt blew up on the launch pad. But the second attempt succeeded. That was January 31st, 1958. It was almost 120 days after that initial launch. It's pretty fast by modern standards. Then in April 1961, Yuri Gagarin became the first human being to orbit the Earth. And again, that made news all over the world. Everybody was very impressed by that. And back in the United States, people were upset because, again, we're behind. We were behind in what was becoming clear was the space race. And we didn't like that. And what were we going to do about it? So in May 1961, 1 month after that flight, our president at the time, Kennedy, made a speech to Congress saying, like, look, if we're going to catch up and not be behind forever, we have to do something big. We have to commit a lot of money, a lot of resources. We're going to go to the moon, right? And that was kind of a crazy idea. And in 1962, he reiterated this in a famous public speech. And he said, look, we're going to go to the moon before the decade is over. And that was crazy. It was really crazy because we hadn't done anything remotely like that. But lo and behold, eventually we did. So Apollo 11 launched on July 16th, 1969, before the decade was over. And just this year, there's a very good documentary that came out about this whole mission. What it is it's made of all original footage that NASA took during the mission that's been sitting away in cupboards and closets, and they restored the footage, and they sort of made a recreation of what it was like to live through this mission. And I'm going to play a short excerpt from that documentary just to give you a sense of what the scale of this whole thing was like. It's a lot, and it's crazy. We went from nothing to all that stuff in something like 12 years. Before Sputnik flew, we didn't have much of a space program in the United States, and in the end, we had all that stuff. And then, of course, after that, we continued to do space things, right? We made this space shuttle. It seemed like a really cool thing. It's like a ship out of science fiction. It could, like, take off and then land again. That's so great, right? Problem is, actually, most of it couldn't land, like those tanks in the background there, and therefore it was very expensive to fly, and it was very unreliable. People died on this on a couple of different missions, and we decided to stop using it for all these reasons. So after that, if we wanted to put people in orbit, we had to get a ride on the Soyuz, and then from there, the trajectory of our space program kept going downwards. And so if you talk to somebody like me, sometime around the year 2002 or 2005, we all had this attitude like, isn't it a shame? Like, the USA used to do all this cool stuff in space, and now we, like, don't really do anything, and the science fiction future that we visualized isn't really going to happen, and we don't ever see that changing, but what can you do about it? Oh, well, shrug, right? That was just everybody's attitude. But not quite everybody, right? At some point, somebody came along who'd made a bunch of money on a website and said, hey, I want to do something about this. Despite having no rocket experience, I'm going to start a company to launch rockets and to do bigger stuff than we've ever done before. And so here's an excerpt of a video about why he did that stuff.
Then there's becoming a multi-planet species and spacefaring civilization. This is not inevitable. It's very important to appreciate this is not inevitable. The sustainable energy future, I think, is largely inevitable, but being a spacefaring civilization is definitely not inevitable. If you look at the progress in space, in 1969, we were able to send somebody to the moon. 1969. Then we had the space shuttle. The space shuttle could only take people to low Earth orbit. Then the space shuttle retired, and the United States could take no one to orbit. So that's the trend. The trend is like down to nothing. This is not... People are mistaken when they think that technology just automatically improves. It does not automatically improve. It only improves if a lot of people work very hard to make it better. And actually, it will, I think, by itself degrade, actually. You look at great civilizations like ancient Egypt, and they were able to make the pyramids, and they forgot how to do that. And the Romans, they built these incredible aqueducts. They forgot how to do it.
So his idea was pretty successful, and today we're like landing rockets, and we're seriously talking about doing another moon mission as soon as the year 2024. We'll see if that actually happens, but we're at least talking about it seriously, and that's a pretty good thing given where we were not long ago. So Elon talked about a few things from the past that were great achievements that have been lost, and I wanted to go through a few more of those to reiterate his point that technology automatically degrades. This thing here that you see is the Lycurgus cup. This was a relic found and dated back to the Roman Empire, 300 AD. And it's made of glass, and this glass that it's made of is the world's earliest known nanomaterial. Okay? The color of the glass changes based on how you look at it, like where the light source is. So if you're looking at it standing in front of the glass and the light source is sort of over here with you so that you're seeing it with reflected light, then the goblet is green. But if light is passing through it, the goblet is red. They had this in 300 AD, right? And then the Roman Empire fell, and that knowledge was lost until basically forever. The way this worked was actually, it got figured out around 1990. The glass is suffused with very small particles of silver and gold. By very small, I mean 50 to 70 nanometers, which is so small you would not be able to see them with a physical microscope. You would require an electron microscope to see these particles, right? But at some point, the Roman Empire fell, and they forgot how to do it. A lot of craftsmanship went into this. You could see, how it's hollowed out on the inside where the little guy's body is to give him more of a purple sheen as opposed to a red in the background. And if you hear people talk about this today, or you read up on this, they tend to have a dismissive attitude toward it, like, oh, the stupid Romans didn't understand technology. They probably didn't even know it was silver and gold that made this happen. It was probably just an accident, and they made like 5 of these, right? Which is complete nonsense. Like, anybody who actually builds things, as opposed to just writing about them, knows you do not get a result this good without a constant process of iteration and refinement. You can imagine there was some initial accident, like maybe somebody wanted to make glass sparkly and they tried to put silver and gold in it, and then they noticed a little bit of discoloration and they said, like, why is that there? And maybe they pursued that, like, what happens when I change the proportions, right? How thick should the glass be? Like, engineering results this good takes a long time. And what that means is that in Rome, people were doing something that we would recognize today as material science. And then that was lost. Other stuff happened. Like in the Byzantine Empire, they had flamethrowers, and not like little dinky things. They had giant pressurized vessels in the bellies of ships that shot out a napalm-like substance out of metal tubes that they would use to incinerate neighboring vessels. It was napalm-like in the sense that, like, water would not put this fire out, right? It was a very serious weapon. It was a state secret of the Byzantine Empire. They used it to defend Constantinople over and over again for hundreds of years, until one day they couldn't really do that anymore for whatever reason. And this military secret just faded from knowledge. Nobody knows how to do it now, right? Obviously, we've reinvented flamethrowers, but they're different. This is the Antikythera mechanism, which is named after an island in Greece where this was found on a sunken ship. It was just a corroded hunk of metal, or a number of corroded hunks of metal, but it was very clear when they were originally discovered that gears were involved. And over time, people analyzed this. They realized it's a mechanical calendar that was used to say things like, you know, what year is it? What are the phases of the moon? Where are the planets going to be right now? When is the next Olympic Games, right? And people have run scans on what is left of this and managed to deduce what all the gears were in this mechanism. And it's very different from what I thought. When I first heard news about this, I thought like, oh, they must have had some cute little gear things in Greece. That's surprising. But let me just show you the scale of the generally agreed upon reconstruction of what this device actually was. That seems like a lot of gears, right? But wait, there's more. So ancient Greece had that, but that is not the picture that we have today of ancient Greece, right? And the thing to realize is you don't just get here from nothing. It's not like one day there weren't any gears and then the next day some guy makes this, right? You need a whole process of science to create something that sophisticated. And we don't know anything about that today, right? All of that was lost. And I could go on and on with examples. There's a whole bunch of things from history that are like this. But we don't have time. I just want to restate that right now we live in a very privileged time where technology has been in a good shape for a long time. We see it getting better, and so we imagine that the natural course of history is that technology always improves and that these moments in history are just like little blips or something that we heard about. But they're not just little blips. It's actually sort of the regular course of world history that great achievements in technology just get completely lost because the civilizations that made those achievements fell or, you know, had a sort of a soft fall where they fail to propagate the knowledge into the future, right? Technology goes backward all the time, and not just in ancient history, also in the modern day, right? We lose knowledge all the time. So I'm going to read an excerpt from an interview with Bob Colwell, who was the chief microprocessor architect at Intel for a while. But this interview is from before that. It was from the booming days of Silicon Valley when he worked at a startup called Multiflow. They were trying to make a very large instruction word processor when that was a new experimental idea. And they were having a lot of problems. Like when you try to design the chip, you're using components from other manufacturers, and he just couldn't get anything to work reliably. And he was like, what the hell, right? So he says, Rich Lethin and I made a pilgrimage down to Texas Instruments in Richardson, Texas, and we said, as best as we can tell, many of your chips don't work properly, and does this come as a surprise to you? I half expected them to say, what, you're out of your mind, you've done something wrong? Come on, you don't know what you're doing, go use somebody else's chips. But no, they said, yeah, we know, let me see your list. And they looked at the list and said, well, here's some more that you don't know about. And by the way, it wasn't just TI. Their parts were no worse than anybody else's. Motorola's were no good, Fairchild's were no good. They all had this problem. And so I asked TI, how did the entire industry fall on its face at the same time? We are killing ourselves trying to work around the shortcomings in your silicon. And the guy said, the first generation of transistor logic was done by the old graybeard guys who really knew what they were doing. The new generation was done by kids who are straight out of school who didn't know to ask what the change in packaging would do to inductive spikes, right? So when you change the voltage in places on a chip, it generates a magnetic field because that's just what happens. And when those fields interact across a chip, it's bad, right? And you know, the new people designing these chips didn't know to take that seriously. And that's why technology degrades, or it's at least one reason, right? It takes a lot of energy and effort to communicate from generation to generation these important things that you need to know in order to do a competent job making the technology. And there are losses in that communication process, almost inevitably. And without this generational transfer of knowledge, civilizations can die because the technology that those civilizations depend on degrades and fails. So let's talk about a civilization that fell, actually a whole group of civilizations. The diagrams I'm going to show here are from a lecture you can find on YouTube called 1177 BC, The Year Civilization Collapsed, by Klein. And we're talking about the Late Bronze Age, which was the time of a number of civilizations you've heard of probably, like the Egyptians, or the Mycenaean Greeks, right, or the Hittites, the Babylonians. So this civilization, or this network of civilizations, was sort of spanning Mesopotamia and the Mediterranean Sea. And they had developed quite a sophisticated network of trade. So in this graph here, each of these points is one of the civilizations, and the lines are, you know, established communication and trade routes between those civilizations. And whereas not all of them were connected to all of the other ones, they were interconnected enough that you could relatively efficiently route things from one place to another if you needed to. And that was very important, because bronze, which the civilization depended on for things like defense, was hard to make back then. You had to do it by combining copper and tin, and copper was relatively hard to find and was found in places like the island of Cyprus. And tin was also really hard to find and was found very far away from those copper places, like in Afghanistan. And so you somehow had to persistently ship these things around in order to make your bronze and the other things that your society depended on. And nobody's sure exactly what happened in this collapse, but people believe there was some kind of environmental stressor to kick it off, like there was a huge drought, possibly also some floods are theorized, and this led to some people attacking some other people, and, you know, maybe you need to start using your ships for defense instead of trading, and basically you went from all these flourishing civilizations to 100 years later, none of them were left. And by none of them were left, I don't even mean that, like, the nation states were gone. Like, many of the cities were burned to the ground, and the languages and cultures don't survive. Even though they wrote by, you know, pressing things into stone, like, nobody was able to translate those languages. Even today, we still can't translate a lot of them. So, like, so much knowledge was lost here in this collapse. We'll get back to it later. But so I want to bridge this to the modern day in some way. And my thesis for the rest of this talk is that software is actually in decline right now. It's in maybe a soft decline that just makes things really inconvenient for us, but it could lead to a hard decline later on because our civilization depends on software. We put it everywhere. All our communication systems are software. Our vehicles are software. So, you know, we now have airplanes that kill hundreds of people due to bad software, and bad software only, right? There was no other problem with those airplanes. Now, I don't think most people would believe me if I say software is in decline. It sure seems like it's flourishing, so I have to convince you at least that this is a plausible perspective, and that's my goal for the rest of this talk. And what I will say about that is, these collapses like we're talking about, that Bronze Age collapse was massive. Like, all these civilizations were destroyed, but it took 100 years. So if you're at the beginning of that collapse in the first 20 years, you might think, well, things aren't as good as they were 20 years ago, but it's fine, we're basically the same, right? But then you keep thinking that, every 20 years another couple cities get burned to the ground, and then eventually there's like nothing, right? Fall of the Roman Empire was about 300 years. So if you're in the middle of a very slow collapse like that, would you recognize it? Would you know what it looked like from the inside? So of course I expect the reply to what I'm saying to be, you're crazy, software is doing great. Look at all these internet companies that are making all this money and changing the way that we live, you know, and I would say, yes, that is all happening. But what is really happening is that software has been free riding on hardware. For the past many decades, we've had amazing advances in hardware technology. Computers keep getting faster and faster. It's really one of the greatest accomplishments in human history that we've somehow managed to do that. And software gets better, in air quotes, because it has better hardware to run on. That's the main reason. Software technology itself has not improved in quite a while, I claim, right? And you can say, but look at all these examples of cool stuff we can do, even in the past couple of years. So like AlphaGo was an AI that'll beat human players at Go. And you can go on like Instagram or whatever app and like make your face look like somebody else's face. That's crazy. We didn't used to be able to do that. And that's true. But most of these, again, are products of hardware being fast. Most of these cool things that we do now are due to machine learning algorithms. And it's, those really are relying on quantity of computation right now to produce impressive results. It's hard to imagine being able to train AlphaGo 20 years ago on the computers we had at that time, right? So it's not there are software technology improvements here, right? Machine learning algorithms have legitimately gotten better, but there's two things to say about that. Well, the main thing to say about it, I will say, is just that it's a minority of actual software technology, right? So of the volume of things that we run, the thing that runs the machine learning algorithm that produces the actual impressive result is a very small piece of the program. It's actually really simple once you understand the math, and especially if you don't have to train it, if you just have to use it, right? And so when you take an app on your phone like that does something funny with your picture, the part of it that does the thing that we think is cool and really value, that piece of software is tremendously simple compared to all the stuff about like loading the bitmap for your face or responding to user input events, right? That part of the software is huge and complicated and is the part that's kind of falling apart. So I would characterize software as having small local technological improvements like machine learning, with overall inertia or degradation in the rest of the field. And we're very impressed by the improvements, though, right? And let me illustrate the degradation part as best I can. And it's to say that we simply don't expect software to work anymore. And I'm not sure when this happened. Computers always had a reputation for being a little bit funny, but if you go back many decades ago, it was generally due to like not being user-friendly or hard to understand how to use it. But today, if you're using a program and it does something wrong, you're just like, yeah, it's software, restart it, whatever. And that didn't used to be. And if our standards are shrinking over time, how low can they shrink before it becomes unsustainable? So I decided to say, I want to quantify or illustrate how much I put up with this from day to day. So from now on, I'm just going to take a screenshot every time any piece of software that I use has an obvious bug or unintuitive or incorrect piece of behavior. And right when I decided that, I was working on my compiler in the command line, and the console that I use, after a while, just starts saying attempt to index a nil value in the prompt because it's written in Lua for some reason. Then I go to Emacs, and I'm working on my code, and Emacs is set to reload files that have been modified, and that used to work fine, but at some point they broke it so that it reloads the file too early and doesn't get the whole thing, and half of it is cut off, and I have to like manually reset that every time it happens. Then I go to Gmail, and I'm going to send an email to the rest of the team about some graphics stuff, making decisions about what to do, and I copy a line of a previous email and paste it into the reply box. And then I start typing my reply, and it goes into like a 3-character wide column over here because somehow they've managed to reproduce all the kinds of stupid Microsoft Word formatting bugs that everyone was frustrated with in the 90s and 2000s. Now those are in Gmail, and I don't know how to fix it. Like, you fight with it for a while to get it to stop happening. You have to like delete something invisible. I don't know. Very annoying. So then I say, okay, I'm going to get some real programming done. I go to Visual Studio, and I say, I'm going to type in my command line arguments up there. And as soon as I do that, we get this box that says, hey, collection was modified. Enumeration option may not, or operation may not execute. Why? I don't exactly know why that's a problem. Like, I'm just telling it a string. We're not even trying to do anything with the string. It's just like, save this for later for when we want to run the program. But apparently that's too hard, right? And this is far from the only problem with Visual Studio. Visual Studio has many, many bugs, but this is the funniest one because it's so simple what I'm trying to do, and it can't do it all the time. I don't know what percentage of the time this happens. It's probably like 5%. I don't know, 4%. So then I decided to blow off some steam and play some games. So let me download a game on the Epic Store, but we're unable to start the download for some reason. So maybe I'll go to Steam because that's a more reliable, longer-lasting store. And I'm able to actually download a game, but then when I go to the install window, it's just like a black window, and I have to restart Steam to play the game. Then I manage to play the game, and then I alt-tab out for a second to check something, and then now full screen is all messed up, and the game's like up in a corner of a window, right? And then I have to restart the game to get full screen again. And then I'm watching some Counter-Strike. There was a really good match between Cloud9 and Luminosity Gaming about a month ago. And, but for the entire match, there was a mysterious sixth player on the Cloud9 side called Undefined up in the corner there. Let me zoom in on that map for you Counter-Strike fans. It's Undefined is on the left. 100,000 people were watching this match, and it was there the whole time. I was thinking about a game I like called Ultima 4, so I went to this website that had the map, and the map was like screwed up because it was like wrapping into extra lines, so I opened a different browser to see it correctly. I needed to get a visa to come to the Russian Federation, so I go to the visa site, and I start typing my information, and maybe I typoed my phone number, or I put the +1, and it didn't like it or something. So it says phone number is invalid over here. But I couldn't fix the phone number. No matter what I put in, it wouldn't accept it, because whatever the variable was for phone number is invalid would never get reset. So I had to, like, stop the application, close the website, like, clear my cookies, go back, and reapply in order to be able to, and be very careful when I was typing my phone number. There's just so many of these. All of this was within a couple days. Like, I didn't have to try hard to find these, right? I just had to stop collecting them. But then I come here, and as if to give me more examples in this talk. So here in this hotel, where I've been writing this talk for a couple days, they have this software-controlled heating and lighting system where it's like you kind of push the non-button buttons and things happen. And some percentage of the time, not all the time, when I turn the air conditioning on or off, the phone rings. It's not a full ring even. It's just like a little bloop, 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 and then it stops. But I know it's not intentional because it doesn't happen every time. And I am not making this up. This actually happens in my room right now. Okay? And then, for this talk, 2 hours ago, I was working at the last minute to make a diagram, and I downloaded fully legitimate licensed Creative Cloud Photoshop to my machine. The first thing I do is go File, New Document, bam. The new document extension could not be loaded because of a program error, right? And so my whole point, though, is we are not surprised by any of this. My other point is that it's getting worse over time. So try this every day yourself, because we've gotten used to it. I didn't even think it would be as much, when I had the idea to record this, I didn't think it would be as much as it was. Try counting for yourself just every day. Just make a little list of all these things, and I think you'll be surprised how many there are. I don't know if anyone knows what this phrase means, 5 nines. I'm sure a lot of people don't. This used to be a very common phrase in the 1990s and 2000s when people wanted to sell you software or a hardware system. What it means is this system is up and working and available 99.999% of the time, right? 4 nines would be 99.99, whatever. And we don't use this anymore. I think in part because the number of nines would be going down and we can't make it go up again. And nobody, well, certain parties don't seem to care. So I was, working on this speech for about the past week, and twice, once when I was asleep on the airplane, and once the other night in the room, my laptop just rebooted while it was in sleep mode and just killed all my programs and stuff. I guess because it was an update. Maybe it wasn't an update. Maybe it was just the operating system failing, but I think it was an update. So that automatically takes my laptop down to like 3 nines. Or less than 3 nines. And if the laptop is less than 3 nines, nothing running on it could be 3 or 4 or 5 nines, right? So we've even lost the rhetoric of quality that we used to have, right? And so if you say this kind of thing, that software is buggy, then people like web programmers or hacker news people or whatever will say, yeah, we know, but the market won't pay for it, right? Like, we could make software better, but that takes time and money to fix the bugs and all that stuff, and our client won't pay for it, or the market punishes that because you take longer to get to market. And that's true to some extent. I could definitely argue with some parts of it. But here's the thing that I'm thinking today. If you haven't seen an entire industry produce robust software for decades, what makes you think they actually can, right? They're saying we could do it if we wanted to, but we're just totally not. But why would I believe that they actually can do it, right? Because, like we've said, there's this generational transmission of knowledge factor that I don't think is being passed along, right? So I think the knowledge of how to make things less buggy is lost. And even the knowledge of a technology company has changed. And again, this illustrates the difference between software and hardware. A hardware technology company used to be a place that makes advanced materials or designs new radar, or like does something that you didn't used to be able to do before, right? So now in Silicon Valley, and as nearly as I could tell around the world, a software, quote, tech company is just a company that does stuff with computers and is then hoping to stumble into a market niche that it can exploit. And the point is the market niche. The point isn't the software, and the point is especially not designing higher tech software that pushes the threshold of technology forward, which is what hardware companies always used to do. And so we've even corrupted the words tech company, right? Okay, so now I want to bring it a little closer to what we do. There's been this sequence of abstraction that we've gone through as programmers over the decades, right? Originally, you had to program your computer in machine language. Then there was assembly language. Then we had this sequence of higher level languages like Fortran and C or C++. And nowadays, we have stuff like C# or Haskell or JavaScript that are even further away from the machine. And the justification for this is like, look, we're working at a higher level of abstraction. The higher your level of abstraction, the more work you get done because you don't have to worry about scheduling machine instructions and stuff. So we're really being smart and we're saving effort. And I think that's actually true. Like, I don't think we want to program things in assembly language. That's a waste of time. But somewhere through this chain, it becomes wrong. And that's how people are wrong a lot of the times, right? Like, you start out by being right, and then you extrapolate it too far into wrong territory. But the important thing to all of this is that we only see one side of it. We see that we're being smart and saving effort, and we don't see the flip side of all of these things, which is that there's a corresponding loss of capability, right? Because I don't program in assembly anymore, I no longer am able to program in assembly, right? If I don't, if I use languages that are too high level, and I'm a little bit lazy, as people often are, I don't know where my variables live in memory or what they look like or even how big they are, right? I certainly don't know what the CPU is doing in response to the code that I've written. I'm maybe scared to use non-managed languages because the very idea of memory allocation just seems too hard and scary. Or even if I'm a person who programs in a non-managed language, maybe I'm afraid of pointers and start generating this cult of being afraid of pointers and what to do about that, like the modern C++ people do, right? And so the rhetoric that we have is, I'm being smart, I shouldn't have to do the low-level stuff, right? But part of the reality is the loss of capability that corresponds to those choices. And both of those things can be true at the same time. I'm not saying that we're not being smart by going up some level. Well, a little bit. I mean, there's a problem, which is that the point of going up all these levels is supposed to be to make everybody more productive. But programmers are not more productive now than they used to be. In fact, it looks to me like productivity per programmer is approaching 0, and if that's true, then where's the proof that going up this ladder of abstraction further and further is really helping? So the way to at least, get a feel for this is you look at a company like, Twitter or Facebook that employs a lot of people. And you look at their product and you say, how much does that product change from year to year, right? How much functionality is added to Twitter year after year? How much functionality is added to Facebook? It's not that much, right? And then just divide by the number of engineers at the company, right? Which is thousands or tens of thousands sometimes. That's a very small number when you do that division, right? It's going to be pretty close to 0. So what's going on, right? And to illustrate again the difference in productivity, and that it's not just me that thinks this, I'm going to show an excerpt from an interview with Ken Thompson, who is the original author of the Unix operating system. And he's talking about the time at Bell Laboratories when he first started making Unix on a computer that by modern standards had like no software at all, right?
At some point, I realized, without knowing it up until that point, that I was 3 weeks from an operating system with 3 programs, 1 a week. An editor, I needed an editor to write code. I needed an assembler to turn the code into language I could run. And I needed a little kernel kind of overlay, call it an operating system. And luckily, right at that moment, my wife went on a 3-week vacation to take my 1-year-old, roughly, to visit my in-laws who were in California. Disappeared all alone, and 1 week, and we had Unix.
Yeah, I think programmers aren't quite as productive these days as they used to be.
Yeah, he says programmers aren't productive these days like that, and everybody laughs. But it's funny, but it's not funny, right? It's really not funny when you consider like how much waste there must be in the difference between how productive people are and how productive they could be if everything wasn't so messed up, right? So I've made a case that robustness of software is declining, productivity of programmers is declining. So if you're going to say that actual technology of software is somehow advancing, it seems contrary to those two facts, right? So I think the argument that software is advancing is clearly false, except again, maybe in tiny local bubble-like areas. So now, why is it so bad? Why is it so hard to write programs? Why are we so miserable when we try to write programs today? It's because we're adding too much complication to everything, right? And I have a way that I think about this called you can't just, right? Where there's all kinds of things that you used to be able to do on a computer that you can't do today, right? So today, you can't just copy a program from one computer to another and have it work, right? You need to have an installer or like a flat pack on Linux or like containers if you're a server Hacker News guy, right? And so people think this is cool, oh, now we have containers. That's an advantage, or it's an advancement of software technology. All containers are doing is get us back to the 1960s when we didn't have to do any of this stuff, except it's actually not because it's adding all these steps that you have to do, right? And things you have to maintain. So now let's think about for a second, like, why do you need an installer to install software? Is it because of the CPU? Not really. Like, imagine you have, well, you know, imagine you have some x64 machine code, and don't worry about how you got it into a computer's memory, but you just got it there, and you just jump to it. You set the program counter to that code. That code is going to do the same thing on a Windows PC as it does on a Mac, as it does on a Linux machine, as it does on an Xbox, as it does on a PlayStation 4, all right? Because all of those systems use compatible CPUs. So what's the installer for? The installer is to get around the incompatibilities that we added at the OS layer, which is this immensely complex thing that we mostly don't want, actually. And so we tend to think about operating systems as adding capabilities to a system, to the system of the hardware and the software. But they also remove capabilities like compatibility, right? And it's often very arbitrary. And it doesn't get any worse than I think it does for us today when it comes to shading languages. Anyone who ships 3D engines is going to know what I'm talking about. So it used to be that if you wanted to compile a program for many platforms, you could write it in some portable language like C or C++, and you might have to do some little if-defs to modify it for the different platforms, but you could do that, and it's mostly the same program. Today, you can't do that because we've decided if you're running a shader, it needs to be in a different programming language on every single platform, even if the hardware is the same, right? So if you have an x86 CPU and an NVIDIA GPU, then on one OS, you need to write your shader in metal shading language, and on another OS, you need to write it in HLSL, right? And they're different, even though they're the same. And so you either have to rewrite everything n times, where n is large, or you have to start using auto-translation systems to rewrite your shaders, and those come with a lot of complexity and annoyance and bugs. And why, though? A shader is a simpler program than the old programs that we used to write. But why have we made it harder to build a simpler program? It doesn't make any sense. We don't care, right? So the list of things you can't just do. You can't just copy a program. You can't just statically link. You can't just draw pixels to the screen. Oh my God, the number of steps you have to do to draw a pixel today is crazy. You can't just write a shader. You can't just compile a program on Windows without a manifest and stuff. And on these new closed platforms, you can't just run an executable unless it's signed through this whole process, right? And all of these things and many more that are not on this list add friction, bugs, time, engineering time, and headspace that keeps us from thinking about interesting things to actually do. There are a couple of examples of this that illustrate this isn't going to end anytime soon, have entered my own life. So one of my side projects is a compiler, and to compile programs, you need to link them against libraries on people's machine, like, for example, the Windows SDK and the C runtime library. And now different versions of things install those in different places on the machine, and so you have to be able to find them to do the linking. And rather than make this easy, today Microsoft gives you a program called VSware, which you can find on GitHub. And the job of VSware is just to tell you where these libraries are installed. It is more than 7,000 lines of source code in 70 files. Okay? And they didn't even try to bundle it as a library. It's a standalone program. So what they're thinking now is, you can't just make a compiler that's a standalone program. It's obviously going to be a suite of applications. And once you have a suite of applications, what's one more? What's like a little VSware hanging out in there, right? They're not even thinking that this would be bad. It's crazy. I made my own version of this based on some other people's work and got it down to 500 lines of code, which is still way too many to basically ask 2 questions that should be 2 lines of code, right? It's a multiplier of 250. And then, also in the programming language world, there's this thing called Language Server Protocol that is pretty much the worst thing that I've ever heard of. And there are just proponents of this all over. They're building systems for this right now that are going to be living on your computer tomorrow, or today. Already, maybe. And as far as I can tell, it's basically a more complicated, slower way to do libraries. So say you've got an editor for some programming language, and you want to be able to do stuff that we've been doing for decades already, like look up the declaration of an identifier by clicking on it, or have tooltips that say, what type is this value, right? Well, they say the way you should do that is, you have your editor, and then it's a hassle to make plugins. This is the made-up problem. It's a hassle to make plugins for all these different things. So in order to standardize, you're going to run a server on your machine, and then your editor talks over a socket to the server, and the server talks back and gives you the answer, right? Which has now turned your single program into a distributed system. But the flaw in this whole line of thinking that none of these people seems to actually think about at all is that there's nothing special about looking up the location of an identifier in your that's just an API we have all the time for everything. So the obvious next step, if you're saying that we should architect our APIs like this, is to do this for other tasks, right? So now your editors or whatever program is going to be talking to multiple of these things. And now if you ever want to author anything for this, you now have to author and debug components of a distributed system where state is not located in any central place. And we all know how fun that is, right? But of course, libraries are not that simple, right? Libraries use other libraries. So what happens at that point is you're running all these servers on your system, and some of them are going to go down and have to restart, and people are synchronizing with each other. No, this is a disaster, right? And people are actively building this right now. And meanwhile, while we're spending all this time overcomplicating stuff that we used to be able to do in 1960, in the games industry, we're not even able to do the things that we've needed to do forever. So like, today, games can't run consistently in full screen, as you see from the screenshot. And I don't wish to bag on that particular game, because we all put a lot of engineering work into trying to make our game run in full screen. It's kind of embarrassing. Like, why, right? Also, it's actually impossible on a PC right now to render at a smooth frame rate. It is simply not possible no matter what you do. Alan Ladovats of Crow Team has a talk at GDC and a paper about what you actually would need to do this. We just don't even have that capability, which is insane, right? And yet we're spending all this effort on other things. And so this complication that's introduced into all of our systems not only makes our lives difficult in the present when we're trying to build something, it accelerates the loss of knowledge over time, right? So first of all, there's more to know when things are more complicated. And so if you talk about a job spread among many people, each individual person knows a smaller percent of what they need to do. They have a less global view, which makes it harder to do good work, right? And harder to transmit their knowledge onto people in the future. Another thing that happens is that deep knowledge becomes replaced by trivia. So deep knowledge might be a general concept, like here's how cache coherency works. And that enables software to run fast on like different processors and stuff. And trivia is something like, well, this sprite in Unity doesn't display properly for some reason, but we know we can fix it if you open this panel and toggle this Boolean, and that fixes it for a while, but then some weeks later, for random reasons, the Boolean mysteriously untoggles, so just make sure to check that before you ship, and it'll be fine, right? And the reason that's trivial is not only because it doesn't apply to anything else in the world, but it's also going to be outdated in 6 months when the next Unity comes out, and it's just offensive that we're spending our brain power on these things. Okay? And the third thing that happens is good information is drowned by noise. So if something is really hard to understand, the percentage of people who put the effort into understanding it is going to be small. And the harder it is, the smaller that percentage. And so if you ask people, or you learn at a school, or you search on the web, your probability of getting a bad answer to the problem is much higher for more complicated things than it is for less complicated things. And so the complication propagates and magnifies. So let's get back to this collapse of civilization stuff, right? The more complexity we put in our system, the less likely we are to survive a disaster, right? Because we have to maintain all that complexity. We're acting right now like we believe that the upper limit of what we can handle is infinity amount of complexity, right? But I don't think that makes any sense. So what's the upper limit? How would we decide how much complexity we can handle? And that's different from what people today actually can handle. So if you have an engineer who can hold a whole system in his head that's really complicated and work on it, when that guy quits and needs to pass on his job to somebody new, he's not necessarily going to be able to communicate all that, right? So the amount of complexity we can sustain over time is less than the amount of complexity that individuals can do today, right? So why am I talking about this at a games conference, right? Like, everybody knows that games aren't serious and whatever, right? But video games at least used to be about maximizing what the machine could do and like really impressing the people playing the game. And maximizing the machine means you have to understand the machine very well, and that correlates with robust software, because if you understand the machine well, you're less likely to make the kind of bugs that come from misunderstanding. There's anti-correlations with robust software too. But anyway, now we're not really about that so much. Especially talking about independent developers, people are shifting to Unity and Unreal en masse, right? Not very many people write their own engines anymore. So we have entire generations of programmers who have grown up learning to program by, making little C# snippets that just plug into other parts of Unity or something, and they've never written something systemic, and they've never written something low level. Which on the one hand is fine. Like, I'm not saying we shouldn't do that, because there's a degree to which it's smart. It reduces development time, right? It helps you ship your game sooner. But, like I said before, there's a flip side. That flip side is giving up the capability of doing the other thing, giving up the knowledge of how to do the other thing. So I don't think it's bad in isolation if a lot of people make games where they just put snippets into Unity, right? But if everybody does that, then nobody knows how to do anything but that. And then after a while, what's going to happen? Because we're assuming that we'll just be able to use these engines forever. But Unity and Unreal were created in an environment where there were lots of people at games companies making engines all the time, right? And that's where they hired people from. And when there's no longer a natural way to learn how to make engines because nobody does it, where are Unity and Unreal going to hire employees from to maintain those engines that everybody's using, right? And, you know, to the extent that they can hire people, is the quality of people going to go down because they have less experience? It just takes a long time to ramp up, right? So then maybe at some point, well, certainly at some point, there's not enough people to make a new competing engine. But maybe even at some point, you can't really maintain the old ones, and they just keep decaying over time. That can happen. And so the way I used to think about game developers is kind of like the Foundation in the Asimov books, where we kind of knew how to really program computers. And you know, also some other kinds of programmers, like embedded systems people and high-performance computing people, all sort of knew what was going on with computers. And after the rest of software just kind of decays and falls apart, we still have the knowledge and we could bring it back and give it to people. But I'm not really sure that that's going to happen now, because I just don't know. I mean, I don't know if there will be enough of us doing low-level work, or even people doing high-level work who understand what's happening at the low level while they do the high level, right? So maybe there needs to be a second Foundation. Spoiler alert for anyone who hasn't read the book. So back in the Bronze Age, right, one of the reasons those civilizations disappeared is that the way things were set up was that reading and writing was only done by a small elite class who went to school for years, and this was protected. The public couldn't know how to do this. They probably mostly didn't want to know. And because those skills weren't widespread, they were fragile, so when the society was disrupted, they weren't continued because not enough people could carry it forward. Today, almost nobody knows what's happening on a CPU, right? That skill is not widespread, so it's fragile. And so do we think that this immensely complicated thing that we've built today is somehow more robust than what they had in the Bronze Age with just making bronze? Because that didn't survive. If that didn't survive, why do we think what we're doing now is going to survive, right? And we might have some similar stressors. We might have some climate change issues, right? Or we might have some new stuff. Like, what happens if there's so many cyber attacks that countries just start cutting each other off the internet, right? Now, lots of people in lots of countries can't get to Stack Overflow to figure out how to copy and paste their code. So their code production is impacted, right? Or what happens if China just says, you know what, we're just going to keep all the CPUs now. We don't want to sell you any. What's going to happen, right? None of these things in isolation, I don't think, will bring down civilization, but it can certainly hit the system with a big shock, and if the system is too complex, it may not survive that shock very well. And so I'm just trying to say, like Elon Musk was saying, that technology by itself will degrade. And we need to, as soon as we can, start working against this, right? At every level that we have access to. We have to simplify the hardware we're running on. We have to simplify the operating systems we use, the libraries we use, the application code we write, the communication systems we do this over, like the internet. We have to simplify how we compile, debug, and distribute software, and we have to simplify how people interface with software. And that sounds like really a lot of stuff to do, but the good news is that all of these things are so ridiculously complicated right now that it's very easy to find things to improve. Simplifying any of these systems only requires the will to do it, rather than, and a taste. You have to have a taste to recognize how complicated things are and how they would be better if they weren't so complicated. Okay, now a lot of people are probably like, okay, whatever. Software is complicated, but I don't believe civilization is going to collapse or anything. And so, you know, maybe, but I would say if you're a programmer, you should care about this anyway, because even just your own personal future, like, programmers are not that happy today. We're often very grumpy, and the reason we're grumpy is because we're doing stupid things all the time instead of interesting things. And that's not going to get better if we keep doing things the way that we do them, right? So you personally will be happier if we change the way we do things. And if we do things the way they are now, maybe the future is deeply mediocre in the way that America's space future was going to be deeply mediocre. Now, even if you just want to survive as just an individual game developer, like you're thinking, look, I just want to get my game done, I want to ship it, I want it to succeed financially, even if you just want to have a very limited scope of concern like that, removing complexity is still the right short-term play, even if it doesn't seem like it. I'm sure we all are very familiar with cases like, well, we're going to ship in 5 months, and we're having a lot of problems with this particular system. It's really buggy, you know, it loses people's work all the time, whatever. But we just have to stick with it for 5 months, and it'll be past, it'll be history. And that's good because rewriting it would be a lot of effort. It might delay shipping. And so we're going to stick with it. We're going to stick out the 5 months. And that's always wrong, because always what happens is it takes 2 years to ship instead of 5 months. And so the amount that you suffered from this system is way worse than it otherwise would have been. And maybe, in fact, that system was a large ingredient in why it took so long to ship. So simplify. And in simplifying your own code to solve your own local problems, you're also building institutional knowledge about how to simplify, which sounds really basic, but I would claim we don't even really have that anymore. Here's some references of videos you can watch if you're interested in this kind of topic. Kaci Meritorious' video, The 30 Million Line Problem. Samo Boreas' video, Civilizations, Institutions, Knowledge in the Future. And then Eric Klein's video, which I showed snapshots of earlier, 1177 BC, the year civilization collapsed. And that's all I have to say for now. Thank you for your time.
Wow. Very impressive. Don't you think that the collapse will happen when we reach the point of technological singularity? Because simplifying is, I think, it's some kind of way to prevent it.
You know, once you start saying singularity, it's too hard. The point of singularity is you can't predict what's going to happen.
Sure, yeah. Maybe it'll be bad, maybe good.
Yeah, I don't believe in singularity the way a lot of people do. It doesn't seem realistic to me, but as you get close to that kind of situation, things move faster. And if things are moving fast, they break easily.
Okay. Yeah, it's what about foundation, by the way, right?
Yeah. Well, and one of the objections, because I'm always criticizing my own, like, what is the counterpoint to this? And what if we just let software get really complicated and then just make an AI that understands it, and that's fine? And it's like, okay, maybe, but do you really want human beings to not be able to understand software? It doesn't seem good.
Okay, we have about 5-10 minutes for questions. So if you have one, you can ask. Yeah, come here and ask.
Thank you very much for this beautiful speech and beautiful mind. Welcome to Russia, by the way.
Thank you.
And I've been doing games in GameMaker for 17 years, and we spent 1 year on doing 3D in GameMaker. And I was asking myself a question why we did this, and actually now I know the answer. And I have another thought about it. Friedrich Nietzsche, when he was already an old man, he started to lose his sight, and he couldn't write anymore, couldn't think actually, because he would think while writing. And so he started using Hansen's writing ball. And this was the first typewriter to use. But his style changed. And when I switched from GameMaker to Unreal, as a game designer, saw that my style, my way of thinking changed. Don't you think that tools, they somehow force us to think in a certain type of way, and for you making a new language is somehow to break through this and start thinking wider, broader?
I think I would agree with that. And I would also say, though, you know, because we think with tools often, unnecessary complications or bugs in the tools interfere with the thought process, right? Like you're in flow, you're doing stuff, and then something bad happens, and you're like, now I have to go fix this thing, and you can't do what you were doing. So I definitely think that's important. You know, when I'm making my new language, I'm trying as best I can to get rid of all these complications that don't make sense. But there's so many of them. And some of them are baked into our assumptions because, you know, I learned to program by using these complicated systems. So what I see as simpler may be very far from the actual simplicity that we could achieve because my thinking has been trained on those tools. So we'll see. We'll see how it comes out.
Thank you. Thank you.
Thank you.
Hi. So let's say I'm an indie developer and I'm sold on your ideas. I don't like Unity either, and I want to put pixels on screen with great ease, but I'm not yet ready to write my own engine as you do.
Well, you would have to write your own operating system to put pixels on the screen. So,
so what is the set of currently existing tools I can use, or like?
well, I don't know, because part of the problem is everything is this way. So really what needs to happen is not about specific tools that you use. It's about developing the aesthetics for things that are not a giant, horrible mess. And whatever tool looks like that to you, just use that instead of whatever you're using. And then maybe we could migrate everybody slowly over time.
Yeah, the problem is when I look for ways to like get to the lower level things, I find is like Visual Studio and C++, and it doesn't like help very much. It's super complex and it breaks every time and whatever.
Yeah, I don't know, man.
Thank you very much for your talk. My question is, in 1968, 30 years after the concept of the computer was invented, Edgar Dijkstra said that where the mainframes were having 2 megabytes of memory, even then, Edgar Dijkstra said that the programming is just too hard by its concept to be done by human beings. Are you sure that simplification will help to any extent?
Well, it'll help. Whether it makes them completely understandable by us, I don't know. I mean, I think you could. I haven't read the Dijkstra piece that you're talking about.
It's
but,
called Humble Programmer.
Okay. I think you could rate it by what problem are you trying to solve, right? And how complicated. Like, there's an inherent complexity to a problem, first of all. And so there may be problems that are so complicated it may be hard to understand what the software looks like to solve that. But then there's also added complication because we're solving this with existing systems, and those systems already prevent us from doing certain things. And so there's a difference between ideal complexity and actual complexity, and I just want to get closer to ideal complexity. Whether that's good enough, I don't know.
Thank you very much.
Yeah.
Okay, we have time only for one small question.
Yeah.
And after the session, you can find
Yeah, I'll be
Newton
able
and
to
ask him.
hang out and talk to people, yeah.
Yeah.
Thank you for your talk. There was already some time ago another try to simplify software, appears interfaces, abstraction, JavaScript, function production, and other. Why it gone to the wrong way, and how to take good simplification way?
I'm not. So, which simplification are you referring to?
Interface, abstraction, interfaces, another languages appear in other languages, and operation systems become.
Well, there's a difference between, and I don't think this is understood very well by everybody. There's a difference between simplifying and making a higher level of abstraction. We say that's simplifying, but actually it's actually making things more complicated most of the time because there's more stuff underneath, right? And that's what we have not acknowledged as a programming community. That said, there have been movements in the past of trying to simplify programming, so things like Smalltalk or Logo or languages like that. And I think that those were all good attempts. I think they were all impractical in some way. So like Smalltalk is just, in my opinion, not a good language for writing robust software. And so, you know, it had some good ideas, but it also had some bad ideas, or that were not obviously bad, but it's why nobody adopts it. And so it's a hard problem to solve to simplify in the right way sometimes, but we need to work on that problem. Yeah.
Thank you.
Okay, thank you. Don't forget to rate this session.
Thank you, everybody.
And yeah.